This looks messy, but it's actually really easy. Pause so you can try and solve it. All right, now whenever you have something like this, it always helps to look at the big picture. Right? In this case, you can see that 3 to the power of x is present on the left side of the equation. So it's a great idea to let u, or some other variable, equal to 3 to the power of x. That will then have 3 to the power of x will become u, 27 to the power of x, which is 3 to the power of x to the power of 3, which is of course 3 to the power of 3x. We can write that as u to the power of 3. And then 9 to the power of x is obviously going to be 3 to the power of 2x, therefore that is u to the power of 2. Then the whole left side just becomes u plus u to the power of 3 over u squared. Now, just for organization, we could split the fraction into u plus 1 over u. Now, check this out, because the left side just becomes a very familiar algebra workflow. It becomes u plus 1 over u, and this is equal to 10 over 3. We can multiply both sides of the equation by 3u, turning it into a quadratic. 3u squared plus 3 is equal to 10u. We can transfer the 10u to the other side. Now it looks like a very solvable quadratic. A quadratic that, by the way, we can factor into 3u minus 1 times u minus 3 is equal to 0. Using the null factor law, u is equal to 1/3 or u is equal to 3, which means that if we substitute back u, which is 3 to the power of x, it's equal to 1/3 or 3 to the power of -1, x is equal to -1. And also, 3 to the power of x, which is again u, is equal to 3 or 3 to the power of 1. That gives us x is equal to 1. Putting all of that together, x is equal to -1 and 1. And that's it. Pretty simple. Always look for patterns. Math is about patterns. Subscribe for more.